Okay, so I'm back again with the Scanline algorithm, one sum. This is the lead code sum only, flowers in full bloom. We'll be doing the question after understanding it. We'll shift to the lead code and we'll code it. Okay, so the question is basically this. I've pasted full question over here. It's given like you are given a zero indexed 2D integer array flowers where flowers I is equal to start I end I. Now, what this means? This means that the ith flower will be in full bloom from start I to end I inclusive. From start I day to end I day, consider that it is in full bloom. Okay, you're also given zero indexed integer array people of size n. Okay, this is people array of size n. You're also given that, and this people array will is the time that the ith person will arrive to see the flowers. At that time, the people will come to see the flowers. So we have to return an integer array of exactly size n, where size n is the people size. Okay, so this is 4. So we have to return an array of size 4, where if 0th people come, okay, and he is standing at 2th position, how many flowers he can see. So we have to return number of flowers that are in full bloom when ith person arrives. Okay, let's just quickly go through the example. It is given that flowers 1 to 6. So first flower is in full bloom from 1 to 6. Second flower is in full bloom from 3 to 7. So 3 to 7 is this this full row. Okay, third flower is in full bloom from 9 to 12. So this is third flower in third row, and fourth flower is in full bloom from 4 to 13. So this is 4 to 13. Clear? Okay. So these are all the given. Now when the people 2, 3, 7, 11. So this is people 2, which is at 0th index. This is 3, 7, and 11. So how many flowers he can see? He can see only one flower. First people, the people standing at position 3 will see two flowers. At 7 will see two flowers, and at 11 will also see two flowers. Okay. Now, up until now, what we have done, we have seen that okay, there are n ranges, but here no outbound or upper bound of n is given. That okay, flowers will start from day 1 and go until this particular n. If I'll tell you the exact n, here the range of n is almost like the start I and end I could be 10 raised to 9. It's given that the start I and end I could be start of I is equal to end of I is equal to 1e9. Okay, so there is no use. I mean, how can you make the array of 1e9 size? It's not possible at all to make the array of 1e9 size and do every time L plus plus R plus 1 minus minus. Okay, here one flower we can add every time. I mean, in 1 to 6, one flower is blooming. In 3 to 7, another flower gets bloom. So it's always plus 1. So here, basically, your x is nothing but x is equal to 1. I mean, every time you have to add one flower. So what we can do in this case, as we do not have exact bound, okay, we do not have exact boundary for start and end. What we can do? We can create map in such cases. Okay, map. What map does? Map stores key value pair. What map does? Map will always stores key value pair. Okay. Now, what we can do here? Here, what we can do when 1 and 6 comes, I'll do the same thing. Map of 1 plus plus and map of 6 plus 1, that is 7 is minus minus. Okay. Now again 3 and 7 came. So what I can do again is map of map of 3 plus plus and map of 8 minus minus. Now 9 and 12, 9 comma 12. So what I'll do, map of 9 plus plus and map of 13 minus minus. And the last is 4 and 13. So map of 4 plus plus and map of 14 minus minus. So this is how we have stored. So basically, if you will see what you will get now, what you will get now, okay. So what you will get now is, array, Okay, what you will get now is map of 1 is equal to 1, map of 3 is equal to 1. I'm writing in sorted order. Okay, so just note that. Map of 4 is also 1, map of 7 is minus 1, map of 8 is minus 1. To store in the sorted form, what we will do will not take unordered map. Unordered map will not store in the sorted form. So what we will initialize this as map of int comma int only. This will stores in sorted order according to key. Okay, according to key. Fine. Map of 8 is minus 1, and then map of 9 is again plus 1, map of 13 is minus 1, and map of 14 is minus 1. Now the main question is question. Now what you have to do after doing all these things, what we do, we apply prefix sum. After performing Q queries, we apply prefix sum. Now how to apply it on map? The main question is how to apply it in map. I mean, okay, what we will do now? How we will do the prefix sum in map? And also one another thing. This people array, this 2 3 7 11, whatever the people array is given, okay, this people array will not be always like 2 3 7 11. It's not necessary it's given in this flowers index whatever is there. So this 2 3 7 11 you will be able to find inside the map is not sure. You're not sure that you'll be able to find this 2 3 7 11 all four values inside the map. Okay, so if you have observed one thing up until now is what, if if we have prefix sum of 7 as 3, I mean index 7 as 3 and index 2 as 4, okay, and in between no change, then prefix sum until index from index, sorry, then prefix sum from index 2 to 7 remains 4 only. If you have observed while making the prefix sum, I'll tell you here also. I mean, if you have something at index 1, okay, and the number changing at index, another index, at index, let's say 7, it is changing as 3. So all the in between values remains the same only. It will not change at all. This is one thing. Now, our main question, how to apply this prefix sum in map. So we will traverse in map. Now, how to traverse in map? We will traverse in map and we will do the summation. So always what you can do while traversing in map, we have to change the value of map also while we are traversing. So what we have to do, map of 1 as 1, map of 3 as 2, map of 4 as 3, I mean it's doing 1 plus 1 plus 1, and then map of 7 as again 3 minus 1 will be 2, and then map of 8 as 2 minus 1 1, and then map of 9 as again 1 plus 1 2, and map of 13 as 1, and map of 14 as 0. This means that at first index there will be one flower, at third index there will be two flower, at fourth index there will be three flower. We can check. At third index two flowers, at fourth index three flowers, at seventh index two flowers, at seven index two flowers. That's true. At seven index there are two flowers only. But as you can see, at fourth index there are three flowers, and then directly we have value of 7 which is changing from 3 to 2. So at fourth index, we have three flowers, and at seventh index, we have two flowers. So in between all the values, 5 and 6, both should have same flowers as what the fourth index has, because it is changing directly as 7 and all the changing values we have stored in the map. Correct? All the changing values we have stored in map. So in between values has the same flowers as the previous value, as the nearest value. Okay, on the left side. On the left side, I mean for 6 4, for 5 4, okay, for 10 9, for 11 9, for 12 also 9. Okay, and for 15, 14, like that, nearest left side value. Now what we will do? We will make one int sum which is equal to 0, and now we will traverse in map. Okay, so for traversing in map, this is the pattern for auto ampersand element in map. In this way, we can traverse the map where element dot first is your key and element dot second is your value. I mean, it will go one by one. First time it will come this one and this one. Second time it will come 3 2. Third time it will come 4 3. It will come as a pair where element dot first is your key and element dot second is your value. And this is the method to traverse the map for auto ampersand element in map. Clear? So what we will do? We will increment this. So understand this as the prefix sum, not stored in the vector or anything, but as a variable. And now we will change its value. Now we will change maps value. So maps value is nothing but element dot second. We will put it as sum, whatever we have got after prefix sum. Clear? And and now the main question is, this way you have done. Now okay. Oh, why is this got messed up? Okay. Now you've got like people 2, 3, 7, and 11. Okay, so for 2, what you will do? 2 is not present in map at all. So how many flowers at 2? Whatever is there at 1. Correct? It's 1. And then 3, it's 2. And then 7, it's 2. And then 11, it's not present. So we'll take whatever is there at 9. But how we will check what is the nearest left side number? How we will check that? So there is the simplest method in STL called the upper bound. We can apply the upper bound on map also, on the set also, and on the vector also. But the easiest method to apply upper bound is on the vector or the array. You just have to write STL function of upper bound. What upper bound does, I'll tell you now. So for that, we need to store this all key values, just key values inside one vector so that we can easily apply upper bound on it. So we'll just quickly take one vector, and every time while we are traversing only, do not need to traverse it again also. What we will do, we'll just store the key values. Okay, no need of this thing. This already, this after running this loop, your map will be stored like this only with the prefix sum values. Okay, so now what your v vector contains, your v vector contains 1 3 4 7. These are all key values: 1 3 4 7, 8 9 13 14, 8 9 13 14. This your v vector contains. Now, what is the upper bound? That's the main question again. What is the upper bound? Upper bound is nothing but to find upper bound of value v is nearest value in vector v, in vector which is just greater than v, which is just greater than v. So now tell me, what is the upper bound of 4? Upper bound of 4 is nothing but, if 4 is present still, I have told just greater than 4. So just greater than 4 is what? 7. And then upper bound of 5. Upper bound of 5 is what? Just greater than 5 is again 7. And then upper bound of 12. Just greater than 12 is 13. Okay. So this is how the upper bound works. Just greater than something. Okay. Just greater than 14. Okay. Now the main question is, what is just greater than 14? What is the upper bound of just greater than 14? Okay. Upper bound will give you the index iterator. Okay. It gives index iterator. It will never give you value like for upper bound of 4 is 7. No, it will give the index of this 7. Okay, it will give the index of this 7, and this index is not the array's index like 0 1 2 3. It will not give 3. It will be something array dot begin plus 3, so kind of an iterator. Okay, it's not an integer or anything. So this will give you array dot end or v dot end. This means you have reached the end of the vector, but you have not found any value greater than 14. Cool. You have not found any value greater than 14, so it will return you v dot end. This way upper bound works. Now what we will do for 2? Okay, we have example of 2. For 2 we have no value of 2, so we will check. Do we have value of 2 in map? No, no, we do not have value. So what we will do? We will do upper bound of 2, upper bound of 2, and we will do that iterator minus 1. So we will do minus minus of that iterator. Same for all these cases. Even for 4, we got 7. Okay. But for 4, it's true. If 4 is present, we have to take 4 only. So we'll do minus minus of 7, iterator. This is iterator. Please keep that in mind. Okay. So if we'll do, this is the iterator which I have got. Okay. For 4, this is the iterator which I have got. I'll do minus minus of this iterator and I'll come to 4. Same way for 5. This is the iterator which I've got. I'll do minus minus of it. I'll come to 4. So that's what I've told you. Na? For 5 also, you have to stick to whatever nearest present in the map. So whatever nearest present in the map, we have found just greater than. So if we'll do minus minus, if equal is present, we will move to equal. If not equal is present, then we will move to one lesser only. So this way we will go to one lesser also. Clear? So now we do not need to check specifically if it's present in map or not present in map or all. And then whatever value will be there from the map, we will return. Okay. So what is the upper bound function? So we will do index is equal to upper bound. If you have to find the index in integer form, we have to whatever upper bound function will apply, we have to minus the begin iterator from that, so that we will get this index in the number form. Just see this in syntax. So we'll do v dot begin, v dot end, and whatever values upper bound you have to found, again minus v dot begin. This will give you one index integer in the integer form. Like here for 4, it will give you third index. Now what we will do? If index is equal to 0, I mean, now you have got index as 0, is no upper bound is found for that. No number is greater than 14. Then you will find it as 0. Then what you will do? You will just simply push back 0 because there are no flowers present only. Otherwise, what you will do? You will just do index minus minus. Okay. You'll just do index minus minus. That means you will move one step ahead. So if I make this clear, if exact value is present, it will go to exact value. Otherwise, one lesser. Because what this index is just greater than particular upper bound you have found. And now what you have to do? You have to just push back whatever map of index. Sorry, not index. You have to go to v of that particular index. Okay, and whatever value is present there, you have to take map of it, and then you have to store it in the answer array. You have to return the answer. So this until this point it's clear, the mapping and prefix sum stored. Now come to this point. Let's say 2 3 7 11 is our people's array. Okay, I'll write it here. People array is 2 3 7 and 11. Fine. So now first 2. So 2 will come. The upper bound of 2 iterator will come to this 3 index. Okay. So index 1 will come. This index will be 1. It's not 0. So we'll do minus minus. So the index will be 0. So v of 0 is what? V of 0 is 1. So once value is present in map, then only it has come. So once value map of 1 is what? Map of 1 is 1. So the answer first value will be 1. So at whenever the people will come and stand at 2 position, he will see 1 flower. I hope you got my point. Now what will come? 3. So for 3 also, you do not need to check specifically if it is present in map or not. The same is this is the generic formula which will be applied to that also. For 3, the upper bound will come like just greater than 3 is what? 4. So if we'll do this index 3 will come. If we'll do minus minus, I'll get, okay, 2 index will come. If I'll do minus minus, I'll get index 1. So it's 3. So I'll take map of v of index will be 1. So v of 1 is what? 3. So map of 3. Map of 3 is what? I'll take from here 2. So I'll store it in answer. Same 7. For 7, it will come in on the 8. I'll do minus minus. It will come to this index 0, 1, 2, 3. Third index. I'll do v of 3, which is 7. And then map of 7, which is what? 2. Again. And then the same thing for 11. For 11, it will go to 13. And I'll do minus minus. It will go to it will come to ninth index, and then I'll do map of 9 is what 2. So 1 2 2 2, it's what your answer, and you can return that. Okay, let's quickly do the code in the fine. Let's just create one map, and for int I0 I less than flowers dot size I plus plus map of flowers of I0 plus plus. This is what our main scanline algorithm is, and map of flowers of I1 plus 1 minus minus. Okay, now for prefix sum we'll take one int sum as 0, and we will take one vector of int v also. Now what we will do, we'll traverse in this map, we'll do sum plus equal to this value we'll go and add as we move in this map. This map is already sorted, and then we will replace its value by map, by sum. And why do we need to store this in v? To make that upper bound. So we'll store only key values because that's what we need. Now we will create one answer array of size n. Now what is n? N is nothing but the people size. Okay, for int I0, I less than n, I plus plus. So int index is what now? Now you have to put the upper bound from this full array v, and you have to put that upper bound or apply that upper bound on people of I minus this v dot begin to get the index. If index is 0, then what? Answer dot push back 0 only. Else we will do index minus minus, and we will do answer dot push back map of v of index. Return the answer. Okay, what is the time complexity? Time complexity is simple, but here we have to store in the map, so it will take log n time complexity to store in the map because it stores in sorted order. Okay, so maximum time complexity will be q log q plus n for whatever this, and even upper bound takes log n times. Okay, this upper bound takes log n times. What is there? Oh, why? Oh, we have done answer dot pushback. That's answer of I. Sorry. If I'm, so this is the new point you can learn also. If you are defining the size of answer as n, then you have to always do answer of I. If you'll do pushback, it will be push back after this n size of 0 0 0 array. So it will create n size 4 size of 0 vector, and then it will append this 1 to 2 value on after that. Okay, so if at all you have defined the answer vector with some size, then you have to do answer of I only while initializing it or while storing the value in it. Otherwise you can do pushback if you have not initialized the size of it. Okay, bye bye. Now we will come with the next video on 2D prefix sum, and then scanline algorithm in 2D, and then range query also in the 2D. Stay tuned until then. Goodbye. Have a good day.